Factoring quadratic trinomials, and in this particular case, solving for them, is one of those skills that is necessary since pre-algebra, algebra 1, obviously here in algebra 2, probably in geometry, definitely in pre-calculus, and for sure in calculus. So please, 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 get this good once and for all. Just get it, own it, and move on with your life. So let's remind you what the standard form of a quadratic looks like. This is the standard form of a quadratic trinomial equation. In this case, it's an equation because there's an equal. The coefficients are going to be A, B, and C. And understanding how to pull off these coefficients to use them is very important for the rest of this topic this semester. So let's say I have this quadratic trinomial and I want to solve for it. But in order to solve for it, I need to factor first. So what are A, B, and C? Well, if you're a noob, you're going to tell me that A is x squared, B is minus 2x, and C is positive 1.
I'm going to put some dirt in your eye.
If you have C level, B level understanding, you'll probably tell me that B is negative 2 and C is 1, but A, you're going to be like, it's x squared, or maybe it's 0 because there's a number there. So you're not doing too bad, but again, this is B level understanding. If you have A level understanding, you would understand that there's a 1 in front of here.
Perfect.
And if you have A plus level understanding, you would make sure to put your signs. So this is a positive 1, a minus 2, and a positive 1.
Anytime you make a mistake, before you get upset with it, look at it.
So notice how the coefficients, right, are just numbers. There's no x's. A is just a positive 1. B is just a negative 2. C is just a positive 1. And there are no x's, no variables, no letters that are equal to the coefficients A, B, and C. A coefficient is the number in front. Okay, so here's that number, and that number. Great. So the AC method, what I'm about to show you, works only if A equals 1. And hey, A is equal to 1. So you draw an X. And I've heard constantly from students that they remember seeing this, but they always forget how to set it up. So it's called the AC method because it's going to use A and C. And let's just talk about a house, okay? In the house, you have an AC, an air conditioner, and it's going to be coming from the ceiling, right? So from the roof. So your AC is on top. Think about the AC, the air conditioner. And your basement is going to be in the bottom, okay? So when you set this up, you don't have to really worry about what goes where if you remember that the air conditioner is on top and the basement is on the bottom. So what is B? B is negative 2. I'm going to put a negative 2 in here. AC, the air conditioner. What's positive 1 times positive 1? Well, that's a positive 1. Please note that if you want that A plus level understanding, I'm using my signs. I'm not just going to put a 1 and leave it there. That is correct. But I want that perfect understanding, and so I'm going to put a positive 1 because I put a positive 1 here. Because I want to keep all the signs so I can keep track of what's going on. Okay, you see how there's these little times right here? That little dot represents multiplication. I need two numbers that multiply to the top, but they're going to add to the bottom. Okay. Now here's where you got to just be good with your times tables. If you're not good with multiplication charts, well, use a calculator and figure it out. But I need two numbers that multiply to 1. Well, that's kind of a no-brainer. We have a 1 and a 1, because 1 times 1 is 1, right? And in particular, positive 1 times positive 1 is a 1. So if I multiply those two, do I get a positive 1? Yes. However, if I add a 1 and a positive 1, do I get a negative 2? No. Well, what if I did two negative 1s, right? So what if I had this negative 1 and this negative 1? If I multiply negative 1 with negative 1, does it become a positive 1? It does. And what if I add negative 1 and negative 1? What if I borrowed $1 from you, but I'm going to borrow one more dollar for you? That means I owe you $2. So my two magical numbers are negative 1 and negative 1. And you're thinking, okay, Mr. Well, why the heck did we just do that? Well, here's why. We're pretty much done with the math. Like, we pretty much factored out this quadratic trinomial. Remember, this is the original problem. We set up this little thingy, and we did the little thingies, right? We did the AC on top, we did the basement on the bottom. We found two numbers and multiplied the top, two numbers that add to the bottom at the same time. And what we do is the factor form is pretty much this, right? We're used to seeing binomials. This is a binomial, this is a binomial, it's equal to 0. And what happens is these numbers drop in here.
Perfect, perfect.
So we're making the absolute claim that this equation is now equal to this setup right here. And then we separate and solve like we've been doing lately. We add 1 to both sides. I get x is equal to positive 1. And I add 1 to both sides. And I get x is equal to positive 1. So this is a special case, right? We've talked about it in the past. But this is called a double root. This is when I get twins, identical answers. We said that quadratics will usually get two answers. We got two answers. They just happen to be duplicates, twins. So this is called a repeated root or a double root.
You win.
So the process of this is, okay, we have our quadratic trinomial. In this case, we're going to use the AC method. So we do the ABC, we do the air conditioner, we do the basement and the bottom. We find our two magical numbers. We plop them in to this setup. We separate and solve, and we're done. We get the two solutions. We get the two roots. We're done with this problem. So notice for problem 2 that all of these have a value of a equal to 1. Let's start off with this quadratic right here. The setup on these is pretty non-mathematical. It's pretty, for those of you that really love math, that's algorithmic, meaning that it is computational, it's repetitive. You don't have to think too much about it. Well, this is your thing. So we're going to just do the same process again. A in this case is a positive 1, B is a positive 5, C is a positive 6. I make my little x, I put AC in the top, B in the bottom. So now so far we haven't done any math at all, and we're already set up. We're going to do A times C, so that's 1 times 6 goes up here, positive 6. Put those signs. The bottom is the basement, that's a positive 5. So far, not too bad. What we're about to do now is going to be the hard math for this problem. Oh my goodness. I need two numbers that if I multiply them, it gives me a positive 6. But if I add the same two numbers, it gives me a positive 5. And so if I'm looking at maybe a 3 and a 2, if I multiply these two, does it give me a 6? And if I add these two, does it give me a 5? Well, the answer is yes. So I'm going to go ahead and drop that number in here. And I'm going to drop this number in here. And now I have factored my quadratic trinomial into two binomials. Each of these is a binomial because there's two terms in them. Here's one binomial. Here's the other binomial. And I separate and solve. And those are our two roots for this quadratic trinomial, and we're done. And if you're feeling like this is too simple and it's algebra 1, and yeah, it is algebra 1, and it should be very simple. The thing is, I need you to be solid with this. Like, we can't be wondering or hoping that you know this. I need to know that you know this for sure, because I'm going to build upon this information. So here we go for part B. A is positive 1, B is negative 5, C is positive 6. A times C is a positive 6. B is a negative 5. Two numbers are multiplied to a positive 6, but they add to a negative 5. Well, it's going to be negative 2 and negative 3. Now, if you're wondering, Mr. It doesn't matter which one goes first or second. It doesn't, because at the end, we're going to get our two answers, and it doesn't matter what order they come in as long as we get them. So if we set that up, we have an x minus 2, x minus 3. The reason why these setups are so easy is because, again, a is equal to 1. Okay, a is equal to 1. If you separate and solve, you're going to get those answers.
I'm gonna put some dirt in your eye.
Just for kicks, let's create a problem E, just to see how it relates to A and B. And so we have A is equal to positive 1, B is equal to negative 5, C is equal to negative 6. Our air conditioner is up there, that's a negative 6, right? A times C. And then our basement is negative 5. This time I need two numbers that multiply to negative 6, but add to negative 5. And so the problem with 2 and 3 is it doesn't work anymore, right? But we know that 6 times 1 can be negative 6. And now it's a question of, okay, is this one negative, or this one positive, or is this one positive, is this one negative? Well, they have to multiply to -6. That means only one of them will be negative. However, it has to add up to a -5. So may I suggest that the bigger number be negative? Because if I multiply these two, I get -6, and if I add them up, I get a -5. And so our factored form for this quadratic becomes x minus 6 times x plus 1 equals 0, and then we would solve for that. So just to compare it to A and B. For part C, I want you to try it out. So I'm not going to do all the steps for you because I've done 3 of them for you already. But try it out, set it up. You're going to get to this point. And of course, if you go ahead and separate and solve, you're going to get as x equals to 8 and x equals -3. For part D, I'm going to kind of give you some of it, but not all of it. So for part D, you might be having struggles with what the heck is going on here. Remember, we always want those numbers as coefficients in front. So I'm going to write D like this, and on top of that, I'm going to put a plus. And so that identifies A as a +1, B as a -1, C as a -20. Because we are not doing letters. There's no x's here. When we do the coefficients, A, B, and C, those are just the numbers. But we're doing a good job keeping track of our signs, so we have pluses and minuses as well. And you would set this up. A times C would be -20. B would be -1. And then I want you to figure out what those numbers will be. And your final answer for this problem will be, your two answers will be 5 and -4. Okay, so that's your final. That's not what these question marks are. These are your final answers. So once you figure out those question marks, you plug them into your binomials, you separate and solve, you're going to get one answer is going to be 5, the other one's going to be -4. Now, one very important thing to bring up is, what if this thing doesn't work out? What if you set up a problem and for some reason this doesn't work out? For example, let me just throw out some numbers. Let's pretend this is 20 and this is 7, right? So what if I can't find two numbers that multiply to 20 but add up to 7, right? So 20, for example, is 1 times 20. Well, that doesn't add up to 7. Or 20 times 2, that doesn't add up to 7. Or 4 times 5, that doesn't add up to 7. And there's no negatives here, so it doesn't work out. So if I set up a problem, and no matter what I do, I exhaust all possibilities and nothing works out, then we say that that equation, that quadratic, is prime. Now, I'm not going to tell you right now that we can't solve it. Yes, we can, because it's algebra 2. But as far as being prime, prime means that I actually have perfect factors that work out. I'm not going to have weird fractions, square roots, decimals. I'm actually going to get a solid, nice couple of answers. And so what happens with this is, if this little thing doesn't work out for us, if this x doesn't work out, this AC setup doesn't work out, then at this point in the game we say that the quadratic trinomial is prime. I can't emphasize how much these summaries are important to your understanding. I've been looking at some people's notes and they are not doing summaries, and it's reflecting on their understanding and their grades on assignments. Please take the time to explain in words the process for not only factoring but also solving quadratic trinomials, equations where a is equal to 1. So you take some time to write down in words, not how you feel about this. Explain the process of how we did these problems.
You're brilliant,
in this set of
you're
notes.
handsome, you're rich,